Hi, it's Yuan, and today I'm gonna show you how to do problem 17.69 in Mastering Physics. Two loudspeakers in a plane 5 meters apart are playing the same frequency. If you stand 12 meters in front of the plane of the speakers, center between them, you can hear a sound of maximum intensity as you walk parallel to the plane of the speakers. Staying 12 meters in front of them, you first hear a minimum of sound intensity when you are directly in front of one of the speakers. What is the frequency of the sound? Assume a sound speed of 340 meters per second. So here are all of the equations we're gonna use in this problem. We have constructive interference is the absolute value of R1 minus R2 equals to m times wavelength. Destructive interference, absolute value of R1 minus R2 equals to m plus 1/2 times wavelength. And we also know that wavelength equals to speed over frequency, and we will also use Pythagorean theorem. So let's select the most information out of the problem here. So in our first scenario, the two speakers are 5 meters apart, and we are 12 meters in front of them. We are also standing in the center, and we hear a maximum intensity of sound. So it means that when we are standing in this position, there's a constructive interference happening. So this is speaker 1 and speaker 2, 5 meters apart. And this is us standing 12 meters from the speakers and in the center of them. So from this picture, we can already tell that R1 equals to R2 because we are standing in the center. So we don't have to worry about what R1 and R2 actually are. So we have constructive interference R1 minus R2 equals to m times wavelength. Since they are the same, this distance will be 0. So in order to make this equation equals to 0, and we also know that wavelength is any positive number, so m must be 0. In scenario 2, as you walk parallel to the plane of the speakers, so this is our initial position as we walk to one of the speakers. Here I'm choosing we will walk to speaker 2. We still stay 12 meters in front of them. You hear a minimum sound intensity. So at this position, there will be a destructive interference happening. And we are also directly in front one of the speakers. So it means that at this point, we are standing 12 meters from speaker 2. So R2 will equal to 12 meters. And these two speakers are still 5 meters apart. So using Pythagorean theorem, I will know that R1 squared will equal to 5 squared plus 12 squared. 5 is this distance, and 12 meters is the distance between speaker 2 and us. So R1 squared will equal to 169, which will give us an answer of R1 equals square root of 169 equals 13 meters. And I also mentioned that there will be a destructive interference happening at this position. So we'll use this equation right here. Absolute value of R1 minus R2 equals to m plus 1/2 times wavelength. So our R1 is 13 meters, R2 is 12 meters, equals to our m is 0, which we already calculated, plus 1/2 times wavelength. So 1 equals to 1/2 wavelength, which will give us an answer of wavelength equals to 2 meters. The last step is to use this equation right here. Wavelength equals to speed over frequency, so frequency will be speed over wavelength, equals to 340 divided by 2, equals to 170 hertz. And this answer makes sense because simply because our math makes sense. And our units are meters. This one has a unit of meter per second, and this one is meters. So this unit right here also makes sense because they all lined up already, hertz. So our frequency is 170 hertz.